All right, welcome back. Today we're going to be getting into working with a couple functions, specifically translate, rotate, and push and pop. So, and we're going to be starting with an example that we've worked with previously in which we drew this little simple desert scene. And all we're going to do today is we're going to make another drawing, and instead of positioning it in the same way that we positioned these elements, using the parameters of the functions such as ellipse and rect, we're going to use translate to position these features and then incorporate some rotation in there as well. So first of all, let's talk a little bit about what translation is. So if we are familiar with translation in Photoshop or Illustrator or any other application that deals with moving images around, we think about translation as moving an object to another location, right? And this is what we're going to accomplish. We're going to draw something that is going to be moved to another location, but this is not the best way to think about it. The way I want us to think about it is that we are moving the origin. And if we remember, in our P5 canvas, the origin by default, if we're using the standard 2D renderer, the origin by default is up in the top left corner. This is our 0, 0 position by default. So I'll just write default coordinate origin. So yes, the top left corner is by default our origin point, our 0, 0. And remember that positive in the y-axis is down, so these values of coordinates down here have a higher y-axis coordinate value, and these going this way have a larger x value. And we have our negative space is up off of our canvas. So when we translate, when we use the translate function, the translate function in our 2D renderer has two parameters, and this is the x translation and the y translation. So if, say, we translate 100 pixels and 250 pixels, this means we are moving the origin 100 pixels to the right and 250 pixels down. So right about there, if in my made-up size of this canvas. So now our new origin is inside of the visible canvas. It's no longer on at the top left corner. So that means that now this is our new 0, 0 position. And if we divide our coordinate plane, we have our values down here have a positive x and a positive y. These up here have a positive x and a negative y. These over here are negative for both x and y values of coordinates within this quadrant. And these here are negative x and a positive y coordinate over in this side. So that means that if we wanted to draw something up at our initial origin, like if we wanted to draw a rectangle that was here, this would now have a x and y coordinate of negative 100, negative 250. Those are the x and y of our old origin. All right. So it can be more intuitive to think of it as having an object move, but for reasons we'll get to shortly, I find it more helpful to think of it as moving that origin point. So let's give that a shot. So going with this, and I'll include a link to this in the description, but let's just draw something first of all. We will draw it. I'll start on line, I'll make another line off 41. Note our numbers down here. And so first thing we're going to do is we're just going to draw an ellipse somewhere. So I'm going to start out by just drawing an ellipse. So I'll say ellipse, use our ellipse function, and if we remember, the parameters for the ellipse function are x, y, width, and height. Those are the, well, x, y, and diameter would be the minimum, but we're going to go x, y, width, and height. So I'm just going to say 100, 200, 60, no, 90, 40, whatever. We'll see that works. All right, and so now I have a green ellipse, and that is green because the last fill that we declared here on line 27 is our cactus green. So if we want this to be some other color, we're going to have to change the fill. So I think what I'm going to do is I'm going to make a little happy face in our desert sun. That'll be what we do to use these bits of code. So what I'm going to do is I'm actually going to remove the fill, and I'm going to set a black stroke. So to do that, remember we can say no fill. We can use the no fill function to make a transparent fill. And I'm going to set the stroke to black, which would be 0. Remember, if we specify one parameter for stroke or fill, then we're going to be setting a grayscale value. 0 will be black. So before I run this code, I'm going to save it. But before I run it, let's just think about what's going to happen here. So remember, stroke and fill, those settings are persistent. If we set them, they are going to be the settings until a new setting comes along, even after we get to the end of our draw function and jump back up to restart our draw function. Because remember, all of this stuff in the draw function is going to run over and over repetitively. So if we just run through, we have our fill being set for the ground. We have our no stroke being set for most elements. We have the ground being drawn. We reset our fill for the sun. We draw the sun. We set our fill for the cactus, and we draw all of the constituent components of the cactus. And now, if we set the fill to transparent and the stroke to 0 for our ellipse that we're working on, that setting is going to be persistent. Well, luckily, it doesn't look like it's actually going to change anything because we have these settings here. So luckily, we don't have to worry about that. But if we had something else that was using the, say, the default settings of a white fill and a black stroke, then that would also be modified. So we just want to keep track of what we are doing. And a pair of functions that can really help us make sure that all of our settings don't modify anything that we don't want to be changing are push and pop. So push and pop, they have a parenthetical relationship. Push comes first, and it has a matching pop to it. And what these do is they act like a save state and a revert, or like a reload a setting state. So this will make it so if I modify my fill, stroke, or translation within the push and pop parenthetical relationship, within that part of the hierarchy of nested bits of code, then that's not going to affect anything outside of that. So one thing we can do, if we're going to be doing any translations, we can surround the code that we're going to be translating or rotating or any of those settings with a push and a pop. So let's just add that in. I'm going to add that in right in line 41. So we're going to say push and after that, pop. And I'm just going to take a moment to put some comments in. Push saves current settings, such as translate, rotate, and fill and stroke. I'm actually going to put that on its own line. And we know what these do, so I don't have to do anything with that. And I will say pop reverts to settings as they were when push was called. All right, so now after this pop, if we do anything else, we're going to be back to green. So let's just take a look at that real quick. So I'll just grab this ellipse, put it after the pop, and I'm just going to change one of these. So now we can run it, and you see now we have a green ellipse because we this settings for fill and stroke do not persist outside of that push and pop boundary. Well, we don't want this ellipse actually, so we'll lose that for now. So we'll save this and let's just update it. So now we have this ellipse. And so like I said, what we're going to be doing in this example is we're just going to be putting a smiley face onto this sun. So the first thing we want to do there is we're going to talk about another function that is going to help us when we get to the rotate part of today's discussion, which is the arc function. So let me just get over to here. So the arc function, arc is going to draw an elliptical curve. So, or a section of an elliptical curve. So the parameters for the arc function, that's what this do. You know what? While we're talking, maybe we can use our handy reference section. So say I don't remember what the parameters of the arc function are, I can always go in here and I can get to the reference section. Has some bits of example code, and if we scroll down, we see the definition of what the parameters are. So we have several parameters that we're going to use. We can see here in this syntax we can have 6 mandatory parameters, and then we can have other optional parameters. So we have x, y, that could be a little clearer, x, y, width, height, start, and stop. So these are the instructions for how to make our arc, which is the section of an elliptical curve, make it work. So first of all, if we have our canvas, just regular old canvas, our x and y coordinates are the center of our ellipse. Our width and height are the width and height of our ellipse. So I'll just draw something similar to what we were doing there. Now the start and stop are a little bit more confusing, especially if you're not used to working in radians. So we'll go to a larger drawing of a circle to talk about start and stop, but basically it's saying which section of the curve we're going to actually draw and which part is not going to be drawn. So let's take a look at that. So first thing we need to do is we need to draw a nice, we're going to start with a circle. Oh, not perfect, but good enough. So we have our x, y coordinates, we have our width and our height, and now we need to talk about that start and stop. So radians are a method for, or a unit, excuse me, for angles. So we might be used to degrees more intuitively, where there are 360 degrees in, like, going all the way around a circle, right? And for radians, there is a different number of radians. There are 2 pi radians. So that's roughly 6.28 radians. But we're not going to use decimals because that can get a little bit confusing if we're trying to divide 6.28 into nice even numbers. What we're going to use is we're going to use fractions of 2 pi. So 2 radians is 360 degrees, which means that pi radians equals 180 degrees. Pi divided by 2 is 90, and so on and so on. So what we can do is let's just draw that out, first of all. So when we're working with radians, we start, at this point, we start on the right side, and so that is 0 radians. In that same position, right, if we take something and we start out pointing at 0 and we rotate it, we get to pi radians on the other side. And if we keep going, then that 360, that means that 2 pi is also right in the same position as 0. So we don't, I won't write that right now, but remember that 2 pi is all the way back around right where we started. So continuing, that means that this right here, halfway between 0 and pi, is pi divided by 2. Up here on the other side is a half of a pi more than 1 pi, so this is 3 pi divided by 2. Right between 0 and half of a pi is a quarter pi, so that's pi divided by 4. And if we go here, this is 1, 2, 3 times this distance, so that is 3 pi divided by 4. And we can subdivide to our heart's content pi over 8, pi over 16, pi over 32, pi over 64, and whatever we want, as much resolution as we care to go within limits. So, these angles are telling us what section of this elliptical curve we're going to show for our arc function, right? So if we have our start as pi over 4 and our end as 3 pi over 4, then that means that this section right here is all of the curve that we're going to see. Similarly, if we started at pi over 4 and went to pi, then we would see all the way through there. So let's stop with the abstract and let's go implement this. So going back to our web editor. So really quick, I'm just going to use this ellipse first to just position where we want our smile to be, because I know that I want like this bottom section of the ellipse to be our smile for our smiley face. So I'm just gonna first get my x and y and width and height dialed in. So going into our code, excuse me, we have our ellipse function, and so I know that this needs to move up, and I'm just gonna go 100, and we'll take a look at that. That looks pretty good. And so I'm going to make it, I'm gonna make it a bit, I think it looks pretty good. Maybe I'll make it a little bit taller, a little bit, a greater height. Yeah, I think that looks like it'll be a nice place for a smile. If we imagine the rest of this ellipse is gone, we just see a bit down here at the bottom of the curve, I think that looks like it should be good. So now what we're going to do is we're going to exchange this ellipse function for an arc function, and we need to add in those start and stop parameters. So just guessing, so I wanted to start somewhere around here and then somewhere around here. So let's go back to our drawing actually. So if I want to make another circle in here, bop. So if we have 0 and pi, pi over 2, pi over 4, 3 pi over 4, pi over 8, and then this would be pi minus pi over 8, so this would be 7 pi over 8 and pi over 8. It's a little small, sorry about that. I think that looks like a pretty good amount of arc for our smile, so let's try that out. All right, so back to here. And let's just try that. We're going to try starting at pi divided by 8. We're at pi. We aren't going to write the symbol pi, but we're going to write pi in capital letters. And we can see that in the P5 editor it turns pink, so we know that it's a system variable that is known. Pi divided by 8. And we'll say 7 times pi divided by 8. Oops, I had my shift key pressed a little bit extra. 7 pi divided by 8. So let's just run that and see what it looks like. I think that looks good to me. So now this smiley face needs some eyeballs. So if we notice, I still have in my console, I'm using this console log function to output the x and y coordinates of my mouse position. So we can use this to our advantage. So I'm going to just use this. I'm going to hover over where I want this mouse to be. So I'm going to say it's about like right around here. Looks pretty good. So I'm just going to say 11590 is where this is going to be. Just estimating from those readings coming out on our console. So 11590. So I'm going to make a small ellipse at that position. 11590. And I'm just going to make it 5 pixels in height and width. So let's just take a look at that. I think I'm going to want to adjust that. I'll make the other eye just to make it even. And so because our mouth is centered at 100 pixels, right, if we have our ellipse, our mouth, and our ellipse, they're all centered at 100 pixels. And if that eye has just been drawn at 115, then that means the difference here is 15 pixels. And so if I want my other eye to be symmetrical, it's going to be at the same y, but it's going to be 15 pixels over from that central line. So that means we're going to move this eyeball over to 85 pixels. And there we go. That's a little bit close together. So I'm going to try 120 and 80. Let's see what that looks like. Yeah, that looks nice. Give them a little bit more space. And let's see, is that good? Yeah, I think that's good. Maybe let's try these a little bit higher up, a little bit less close to the mouth. And let's run that. Yeah, I like that. I think that looks good. So we have these things being drawn, and say now I want to put it at a like a little jovial, friendly, jaunty angle. That means I'm going to want to use this rotate function. So to rotate, let's just give it a try. So the rotate function, like I said, if we're working in 2 dimensions, it's going to just take our excuse me, it's going to just rotate in the x and y. If we were working in a 3D space, if we're using the WebGL renderer, then we can use the rotate X, rotate Y, rotate Z functions independently to rotate in virtual 3D space. But for right now, we're just using the two-dimensional space. So we're just going to specify one angle that we're going to rotate at. But before we do that, we're going to have to talk about translate again. Because what rotate does is it rotates around the origin point. And so right now, because in this sketch we haven't applied any translations, it's going to rotate around this top left corner. So that means if I rotate my face, it's not going to rotate in position in the face of the sun. It's going to rotate around a point off to the side and above. So let's look at it. Let's look at the reference section for rotate first. And we see we have the angle, and we can also specify the optional axis. The default axis is coming out of the screen, so we're rotating in our X and Y plane. And this uses, we'll be using radians here, so we match up with our arc. So yeah, if we haven't translated, it'll look weird. So let's just give that a go. Let's just say rotate pi divided by 8. So now, you see my face has left its background sun shape. So that means that we're going to have to translate the origin down to the center of these face features. And so we want that also to align with the center of the sun, the circle, the ellipse that is the sun. So what we're going to do is before our rotation, actually let's comment that rotation out first. What we're going to do is we're going to translate to the center of our sun. And if we look back here, the center of that sun is at 100 pixels down, 100 pixels over. So we'll say translate 100, 100. And now in turn, we're going to have to modify the X and Y locations of our arc and our ellipses. The ellipses that make up the eyes and the arc that makes the mouth. But before we modify those by subtracting 100 from those X and Y values, let's just look at it and see what happened. So because now we have translated the origin to this 100 pixel over, 100 pixel down coordinate, now our positions that we're using in the parameters of these functions is now moving it even further. So what we want to do is we want to move this arc to 100 less than that, 100 less than this, so 0, 0, 20. And now we're going to be getting into that negative coordinate space that we talked about. This is going to be negative 20. Oh my, negative 20. So let's just take a look at that, see if everything looks good. Oh, what did I do? 85. I forgot to change my y coordinates. That's going to be 85 minus 100, which is negative 15. Negative 15. And now, there we go. That looks a little bit more like it. Okay, so now that we've moved our origin to the imaginary nose of our smiley face, now we can apply this rotation. So I can uncomment this, and remember, the shortcut for commenting is Command/ on Mac, Control/ for PC. And if we run that now, we've rotated our smile a little bit. And if we want to rotate the other direction, then we just need to negate that value. And so now we have our jaunty smiley face smiling over our desert. We'll save, and I will put a link to this code into the description. All right, good luck and happy rotations.